Hello everyone and welcome to Mathematics Galaxy. So after so many long time I am creating this video. So this video is on basically on real analysis. It's basically called the absolute continuity. Okay, so we talk about absolute continuity. It's a special type of continuity. It is like much more stronger than continuity. Okay, so that's what we're gonna talk today, and some definition of uniform continuity and some examples we're gonna meet. Okay, so let's at first start with absolute continuity. So we define absolute continuity on closed interval AB to R because of it's generally easier, but we can define absolute continuity on R to R. Okay, so here we are defining absolute continuity of a real variable of real valued functions. Okay, so at first just see like this, that f maps from AB to R. Okay, just imagine this means that f belongs to the f AB, means function space over the closed interval AB. Okay, now then what is absolute continuity? So to define absolute continuity, at first we have to draw some line. So here is A and here is B. So what we have to do, we will take some non-overlapping intervals inside this AB. Okay, so non-overlapping means, you know, that means that in general sense they are disjoint, that kind of sense. So we want to take some basically points here, let's say x1, x2, x3, xn. So that kind of sense. Okay, that kind of sense we're going to take this kind of points. So for absolute continuity, let epsilon greater than 0 be chosen arbitrarily. Then for this epsilon we're going to get a beautiful delta, and of course we have to choose this pair of points. Okay, at first we have to choose this pair of points. To this pair of points we're going to get this kind of epsilon. Okay, so at first what we're going to do is this, that for all these points, let's say we're going to get this kind of points like xi minus 1 comma xi, this kind of non-overlapping points of sequence. So I equals to 1 to n, we can say. So basically start from x0, they are all non-overlapping. So we're gonna get, let epsilon greater than 0. Got it? Then what we're gonna find like this, that mod of f of xi minus f of xi minus 1, this, so I equals to 1 to n, should be less than epsilon. Okay, should be less than epsilon for all this, that xi minus 1. Basically you can say that like this less than epsilon, so I equals to 1 to n. Okay, so if this kind of situation happens for this epsilon and for this like say non-overlapping points, and if this condition is satisfied, then you can call that the function f is absolute continuous over AB interval. Okay, AB closed interval. So you can vary this point, and that's it. You can vary basically this point. So this delta basically depends on two things. One is epsilon and this points. That is basically the definition of absolute continuity. Okay. Now we define what is uniform continuity. That's another interesting topic. What is uniform continuity? Only the definition and some problems. Okay, for uniform continuity, as you can see, uniform means it is basically everywhere. So that's how I think that uniform means it is basically everywhere. Okay, everywhere means we define uniform continuity on a closed interval, but you can define uniform continuity on R or some other intervals also. Okay, as usual, let us see that f maps from AB to R. So real valued function of a real variable. Uniform continuity means let epsilon greater than 0 be chosen. So okay, at first we choose epsilon as usual. Then what happens like this, that f of let's say x minus f of y, that should be less than epsilon. Okay, for all x minus y less than delta. So let epsilon, then there exists delta greater than 0, and such that this kind of thing gonna happen. So if x minus fy, that should be less than epsilon for all this, and of course this xy, that should belong to closed interval AB. Means that if you take any 2 points from this closed interval AB, what happens that for all these the difference of those points, if that is less than delta, then the difference of their functional values, that should be less than epsilon. Okay, so that is the important thing here. And this delta only depends upon this is basically epsilon. And one of the interesting thing is the main, or you can say the interesting part, which is this, that it basically runs over all those points. Okay, all those points. So that is why it is called uniform. Okay, that is why it is called uniform. Basically, this kind of points, it doesn't depend upon or epsilon or delta, or epsilon delta, it doesn't depend upon this kind of points. Okay, you have to just choose an epsilon. For that, you can get a delta such that this happen, and this xy always runs over this AB closed interval. Okay, so that is the most interesting thing here. That is basically called uniform continuity. Okay, but from the definition, you can see that uniform continuity and absolute continuity, they are general sense they are different, but they have some relation. Okay, for absolute continuity, if you talk about absolute continuity, then it should have to have continuous function. Otherwise, the absolute continuity is basically wrong. All right, and there are certain functions which are basically, let's say, you can say function of BV, function of BV, and there are functions that which are basically, let's say, not continuous sometimes, but of course they cannot be there. Okay, so that's the most important thing, right? You got it? So that's it for today, and we will meet again. Okay.